Okay, here we go with our final gas law, the ideal gas law. This combines everything into one equation. We're not comparing anything. This just describes our gas in one situation when we're missing one of our variables. So this equation looks a little different. It's PV equals nRT. Everything's the same except for the R is the gas constant. There's two different possibilities for R. 0.0821 liters atmospheres per mole Kelvin, and then 8.31 liters kilopascals per mole Kelvin. Now, what I want you to understand right now is these numbers are what you plug in for R. This part right here is the label. So that means you have to look at your volume. Your volume must be in liters. When you look at your pressure, it must be in atmospheres. Your N will be in moles. Your temperature will be in Kelvin. And so this constant allows you to cancel out all the variables you don't need. This one is different because the label here is in kilopascals. If you use this R for your constant, your pressure then must be in kilopascals. Okay, either one is acceptable. You just have to make sure that whatever you're using for pressure matches this label. And again, this part is only the label. It has nothing to do with the numerical part of the problem. Okay. So here's an example. We have 0.55 moles of gas at 105.7 kilopascals and 27 degrees Celsius. What volume does it occupy? So again, we can write down everything we know. We know our N, we know our pressure, we know our temperature. We add 273 to that to get it into Kelvin. And now we can solve for that missing variable. Again, we have everything right here, so we can plug it into our equation. We see here that we have kilopascals, so we're going to pick the R value that has liters kilopascals per mole Kelvin. We plug everything in, and they've left the labels here so you can see the kilopascals here. Are going to cancel out these as you divide by that. The moles on top here will cancel out the moles on bottom here. The Kelvin here will be canceled out by the Kelvin up here. Okay, you multiply 105.7. Excuse me, not multiply. You're going to multiply your 0.55 times 8.31 times 300 and divide it by your 105.7. To get our answer will be in liters because our volume here is in liters. We've got two significant figures here. Only temperature is kind of confusing. Don't use temperature. We've got 3 here and 4 here, so we would use 2 on our answer. 13 liters is going to be your final answer. Another example here. Again, we're going to be at STP in the end, so we have to remember standard temperature is 273 Kelvin and pressure is 1 atmosphere. Here, our initial pressure is in millimeters of mercury. So remember that 1 atmosphere is equal to 760 millimeters of mercury. So we can use that as our second pressure here. We've got a first volume. We're supposed to find our second volume. And then we've got an initial temperature and we've got a final temperature. So writing those all down over here, with our final temperature, we can see that we're going to need the combined gas law. We do not have moles, so that part we will drop out of the equation. Okay, we just will not use the N on each side. We'll plug in everything else we know. If you want to do your cross multiplication, 755 times 15.5 times 273, we'll divide that by 760 times 298. Get our final answer of 14.1. We should only have 2 significant figures because there's only 2 here, so we would want to round this down to 14 liters.